Okay, let's dive in. We're looking at the Tamiya Frog re-release today, Kit 58354. Such a classic.
Absolutely legendary. That ABS space frame, the independent suspension, revolutionary for 1983.
Totally. But let's be real, the handling,
Yeah.
it's known for being a bit wild.
Wild is one word for
Yeah,
it.
yeah.
Yeah, lots of oversteer, and the front end can feel kind of sloppy, especially if you punch it on dirt.
Exactly. You end up driving it slower than you want, just trying to keep it straight.
Pretty much. It fights you a bit.
So our mission here isn't to tame it completely, but, add some predictability, make it faster, but easier to drive fast.
And the key piece of tech for that is the steering gyroscope.
Right. Explain how that actually works. It's not just magic, right?
No, not magic. It's a sensor. It detects yaw. That's when the car starts rotating sideways, like the back end kicking out.
Okay, so fishtailing.
Exactly. And the gyro senses that instantly and applies a little bit of counter steer, often way faster than a person could react.
So it catches the slide before it even really starts.
That's the idea. It helps keep the buggy pointing where you want it to go. Makes it, well, much less likely to spin out unexpectedly.
Now, this is important. You can't just slap a gyro in there with the stock parts, can you? It's more like a system upgrade.
Yeah, that's a critical point. It really is a system. You need the right supporting components.
Okay, like the steering servo. Why does it have to be a digital one? Is the stock one just too weak?
It's less about raw strength and more about speed and precision. An old analog servo. It's just too slow.
Too slow. How so?
Well, the gyro makes a correction command instantly. If the servo lags, it overshoots the correction. Then the gyro corrects that, the servo overshoots again.
And you get that horrible speed wobble.
Exactly, that oscillation you sometimes see. So you need a fast digital servo, like an EcoPower WP110T or maybe a DS Servo DS3218MG, something that can react, correct, and stop precisely.
Got it. Speed is key. And what about the radio? A basic 2-channel isn't enough.
Nope, definitely not. You need at least 3 channels, minimum.
Why 3? What's the third channel for?
Remote gain adjustment. It's essential. Think about it. The amount of grip changes constantly, right? Tarmac, grass, loose dirt.
So the gyro sensitivity, the gain, needs to be different for each surface.
Precisely. You need to tune it on the fly. So radios like the Dunmore CX6 or a Fleisky FSI6X work well. They give you that third channel, usually a knob or switch, to adjust the gain.
And you need the right kind of gyro too, right? Not just any gyro module.
Good point. You want an all-purpose stability gyro, something like a SkyRC GC301 or maybe a Futaba GYC470.
Yeah.
You definitely want to avoid the ones labeled specifically for drift.
Why is that?
They're programmed differently. Drift gyros are designed to help initiate and hold long slides, which is the opposite of what we want for stable driving here.
Okay, makes sense. Now, the Frog chassis, it's that cool but kind of tight ABS space frame. Where do you physically mount the gyro? Is there a good spot?
There actually is a perfect little spot, thanks to the Frog's history.
Oh, yeah.
Remember the original 1983 Frog had a mechanical speed controller with its own servo?
Yeah, vaguely. Big resistor thing.
That's the one. Well, the flat little platform where that MSC servo used to sit is usually vacant. Now we use ESCs. It's central, flat, relatively protected. Ideal for mounting the gyro. Use good double-sided foam tape, of course.
Nice. A bit
Yeah.
of Tamiya history helping out. Okay, so it's mounted. What's the absolute first check? I hear getting the direction wrong is bad.
Oh, it's critical. Catastrophic, even. It's the gyro direction check. Non-negotiable first step.
How do you do it?
Simple. With the power on, you manually pivot the rear of the car to the left, like it's starting to slide out.
Okay.
The front wheels must automatically steer to the right. They have to counter steer against the direction of the slide.
And if they steer left with the slide?
Then it's reversed. If you drive it like that, the first tiny wiggle will cause the gyro to steer into the slide, instantly making it 10 times worse. You'll get a violent swerve.
Yikes. Okay, so find the reverse switch on the gyro or transmitter channel if needed, and test again until it counter steers correctly.
Absolutely. Get that right before you even think about driving it fast.
So directions confirmed. Now, tuning that gain using the third channel. How do you find the sweet spot?
Right, mastering the gain. It's all about finding the maximum stability without causing oscillation. You start with the gain low.
Okay.
Then you drive, preferably at speed, and slowly turn the gain up using that third channel knob or switch on your transmitter.
Right. Keep turning it up until
Until the front wheels start to wobble or shake rapidly back and forth. That's the gyro overcorrecting because the gain is too high for the conditions.
Oh, okay, so you found the absolute limit.
Exactly. Once you see that wobble, just dial the gain back slightly, maybe 5 or 10% down from that point. That's usually your optimal setting for that surface.
So find the wobble, then back it off just a bit. Got it.
And you'll need to readjust it if you go from, say, pavement to loose dirt.
Makes sense. So if you put this whole system together, the fast digital servo, the 3-channel radio for gain, the right gyro mounted properly, and tune that gain, the frog changes character, doesn't it?
It's a transformation. Much better straight line stability, way more predictable, especially coming out of corners when you get on the power. You can actually push it harder.
So you finally get to use the frog's potential without constantly fighting it.
That's the goal. It makes it much more rewarding to drive fast.
And thinking bigger picture, this idea of adding electronic stability to an older, maybe slightly flawed mechanical design, it's interesting, isn't it?
It really is. Think about how this parallels other areas. Like early jet fighters, some were notoriously unstable platforms, made flyable only through complex control systems.
Or even modern drones, right?
Yeah.
They'd be unflyable without constant electronic stabilization.
Exactly. It's not about the electronics driving for you. It's about the electronics stabilizing an inherently challenging platform, allowing the human operator, you, to control it effectively right up to its mechanical limits. It enables performance.